Hello and welcome to My Secret Math Tutor. For this video we're going to learn about some very special right triangles known as the 30-60-90 triangle and the 45-45-90 triangle. And we're going to use these triangles to help us find some key values of our trigonometric functions. So the neat part about these special right triangles is that if you know your angles are 30, 60, and 90, the sides of the right triangle have some common ratios. For example, my legs will be 1 and square root of 3, and the hypotenuse 2. Now, I can already hear a few people thinking, like, wait a minute, I have a 30, 60, 90 triangle, and my sides are not exactly 1 square root of 3 and 2. Watch near the end of this video, and I'll show how even if it's not these exact values, they're actually usually scaled up of these values, and you can still use that triangle to find your key values. In fact, you'll get the same value for your trigonometric functions. So, you want to think of your 30, 60, 90 triangle as having these basic sides as 1, square root of 3, and 2. The way I keep these straight is the hypotenuse, in this case, will always be 2. 1, the smaller side, is opposite my smaller angle, and square root of 3 is opposite my larger angle. Now, in the same fashion, we could have a 45, 45, 90 triangle. Its sides are 1, 1, and square root of 2. The longest side is our square root of 2, that's our hypotenuse, and you'll notice that both the legs are 1. They're the same because both of our angles are the same. They're both 45 degrees. So watch how these two triangles play a part with finding some nice key trigonometric values. We'll start off with trying to find cosine of 30, tangent of 60, and cosecant of 60 degrees. And for this, you're going to want to think of that 30, 60, 90 triangle working in the background. So for cosine of an angle, we want to think of the adjacent side over the hypotenuse. When we're thinking about that 30, 60, 90, and I'm talking about that 30 degrees, I have my adjacent side over the hypotenuse. So this becomes the square root of 3 all over 2. If I want to figure out something like tangent of 60 degrees, now we're thinking about this top angle. So that's the opposite over the adjacent. So square root of 3 all over 1. Or we can just simplify that square root of 3. And lastly, let's go ahead and do cosecant of 60 degrees. Cosecant would be our hypotenuse all over the opposite. So hypotenuse all over opposite. Just to make this look a little bit better, let's go ahead and rationalize the denominator. We'll multiply the top and bottom by square root of 3. So we get 2 times the square root of 3 all over 3. So if I see these key angles in there like 30, 60, this gives me information about the triangle that's really working in the background, and it might be one of these special triangles. Let's do this again with our 45, 45, 90 triangle and get some more good key values. For the first one, we want to do sine of 45 degrees. So I could do 45 in the bottom left here, and that would be the opposite over hypotenuse, or 1 over the square root of 2. Now you might be wondering, wait a minute, how come you don't use the other 45? Actually, it doesn't matter with this particular triangle. Even if I used this 45 degree angle, the opposite over the hypotenuse would still be 1 over the square root of 2. Now let's go ahead and finish this by rationalizing that denominator. So square root of 2 over 2. And there's a good key value for this. Alright, moving on. Cosine. Cosine is my adjacent over hypotenuse. So that's 1 over the square root of 2. And like before, we can go ahead and rationalize that denominator, get something like the square root of 2 over 2. Alright, one last one, secant of 45 degrees. That's our hypotenuse over the adjacent side. So hypotenuse over the adjacent, or just the square root of 2. Not bad. So these special triangles really play a key part with finding these good values. Now, on to what I mentioned earlier in the video. You might end up with a 30, 60, 90 triangle, or even a 45, 45, 90 triangle, and your sides don't look exactly like the ones I started with. They actually are. In fact, you can think of this new triangle, the 30, 60, 91, as really being a scaled up version of what we started with earlier in the video. So our hypotenuse would be 2, our large side is square root of 3, and the smaller side is just 1. And what you really want to recognize between these two triangles is that things have been scaled up. And oftentimes you can use a known side to figure out how much it's been scaled up by. So in this case, this side has been scaled up by 5, and so have all the other sides. Everything has been multiplied by 5 to create a brand new triangle. So what if I really want to find the sine of, say, one of these angles in here? Do I need to use these sides, or should I use the ones that we saw earlier? It does not matter what you use. In fact, we're going to use these sides to show that that scaling factor actually cancels out and it doesn't really play a part. So we're going to find sine of 60 degrees. That's the one in the upper right here. So I'm thinking about the opposite side all over the hypotenuse. So you'll see that I have a common 5 in the top and the bottom that I can go ahead and cancel out. 5 goes into 10 twice, and I'd be left with the square root of 3 over 2. And that's the exact same answer you'd get even if you used our smaller triangle. So sine of 60 degrees would be the opposite over the hypotenuse, or just square root of 3 over 2. That's why you can save yourself some time by memorizing these key values or key sides on the 30, 60, 90 and the 45, 45, 90. Alright, hopefully that helps out. If you'd like to see some more videos, please visit mysecretmathtutor.com.